Statistics is everywhere. You may not see it, but it is all around you. In virtually all fields of study, statistics can play a major or minor role in displaying and collecting information. However, oftentimes, statistics may be misleading. And due to the world's modern civilizations being bound together by technological and data-based contiguity, knowledge of the misuse of statistics is imperative for anyone who does not want to get lost in propaganda and lies.
So, the ideas that I decided to focus on were correlation and causation, the general misrepresentation of statistical data and percentages, and a phenomenon called Simpson's paradox.
Firstly, a commonly misused statistical idea is correlation and causation. So, there are useful statistical methods to determine correlation between, let's say, event A and event B. Now, many people will be quick to assume that event A causes event B. However, it's logical to know that oftentimes it takes more than just seeing the correlation to actually determine the causation between these two events. A common phenomenon in the misuse of correlation and causation is what I'm going to call the third cause fallacy. Now, this is when you have two events and you assume that one is causing the other, but in fact, you lack the information to realize that a third event could be causing both. Now, a real-life example of this actually happened in 2011 when an economics professor and a health policy researcher conducted a study that showed correlation between shark attacks and eating ice cream. They said that if you eat ice cream, you're more likely to be attacked by a shark. Now, what they ignored was that warm weather was the third cause factor that was causing both of them, because when the weather is warm, people are more likely to go out and eat ice cream, and they're more likely to go to the beach, which exposes them to a shark attack.
So, secondly, this is probably the most common misuse of statistics, and that's the general misrepresentation of data and statistics. And this is usually seen in graphs with the manipulation of either the x-axis or the y-axis. So here you can see the percentage of unemployment is shown going down in these months. Now you can see that it goes January, February, March, April, and then it goes to August. And then you see a spike here. Now someone could label this, for example, like a news source can label this, that the slope is increasing, like the slope is more steep. However, you can see that it skips a couple months, so it's actually staying at around the same rate, and this could be shown as a change in the levels of unemployment, where in fact it's actually just constant. Now, on the other hand, another thing that could be done is the manipulation of the y-axis instead of the x-axis. So here you can see in this graph, it doesn't start at 0, the y-axis starts at 80, which makes the change from 88 to 81, which is a 7% change, seem like it's almost double. So this was an actual ad done by Chevy, which showed the reliability rates between their cars, Fords, and Toyotas. I think this specifically was talking about their pickup trucks, and it showed that Chevy's cars were on top. Here, this is actually only a 6% decrease and a 7% decrease between Toyota, and it seems like it is almost double. Now, lastly, the final area that I'm going to explore is the Simpson's paradox. Now, this is when individual sets of data show a particular trend, and when you group all those sets together and you see them as a whole, they show a different trend or no trend at all. So as you can see in this graph, each data set is showing a trend upwards as it moves to the right. But then when you group them all together and you make a graph out of them, as they go to the right, it's actually going downwards. So you see they're reversing each other, and that is what's called the Simpson's paradox. A real life case of this actually occurred in 1973, where UC Berkeley's fall admissions were deemed biased towards men. When looking at all the admissions as a whole, you could see that men were favored towards women. But when a study by Berkeley looked at each individual major and how many applicants applied to it, it was shown that women were actually applying to the harder majors, therefore less of them were getting in. So I'm sure there are actually colleges that are biased against women, but in 1973's UC Berkeley's admissions, the truth was much different. The examples I showed you today were just the tip of the iceberg in all the ways you can be fooled by statistical models. Try to keep these examples in mind, especially in today's day and age where data is everywhere and influences so many aspects of our society. It's crucial that everyone tries to question everything they see and try to examine data on their own instead of just being shown everything. Thank you for listening, and I hope this was very informative for all of you.